All right, this video is going to go through how to do the graphing for the ramp lab. So you've already done this before. This is the practice for the lab. And what I gave you here is I gave you some sample data. So the gray line here represents nice data from an accelerated object. And what we did here was we determined the instantaneous velocity at 4 time points, 2, 3, 4, and 5 seconds. So in your lab, it's going to be a little bit different because you're going to be determining the velocity at 0.2, 0.4, 0.6, and 0.8 seconds. So a little different, but same idea. So anyway, what's going on here is you're going to draw your tangent. So we'll be looking at the 2-second one, which is orange here. You draw your tangent, do it in pencil, and then you determine your coordinates, okay? And you're going to determine the velocity either on the graph or just underneath like we have here. You want to color code everything. So you want to make sure everything is color coded. So this is orange here and your calculation is orange below. Make sure you've got the direction as well. In our case, remember, we're using forward. Then you go into the next one. You're going to have the middle one here. This would be the 3-second data here. So again, same thing. You draw the tangent, color code, you calculate it down below. You do the same thing for 4 seconds, 5 seconds. You have all those data points here. So once we have the instantaneous velocities, we know how fast we're going at 2, 3, 4, and 5 seconds. So what we do is we graph the velocities on a velocity graph. So here's my data. So I got my 4 points over here. So again, at 2 seconds, I graph this velocity, 4.4 meters per second. At 3 seconds, we'll be graphing the 6 meter per second data. 4 seconds would be the 7.25 meter per second data. And at 5 seconds, we're going to be graphing the 10 meter per second data. So it's right here. So you're going to draw a line of best fit. Notice the line of best fit doesn't go through all the data points. That's fine. This is going to be messy. Not all the data points are perfect, but you want to draw a line that best represents the data. Once you've drawn that nice straight line of best fit, you're going to pick your 2 points on the graph. Now, your graph might not go through the origin, might not go through 0, 0 over here. That's okay. Just show the best representation of the data. You pick any 2 points on here, and then use those 2 points, those coordinates, to determine the acceleration of the object. And you include the units. Now, here, the units are meters per second squared. North, you're going to have centimeters per second squared, and forward. So just keep all your values in centimeters and should be fine. So again, very similar to what we're doing in the lab in terms of the expectations. Okay?